you very much, Alexander. And Alexander, I really appreciate the invitation today. And topic of the talk is mobile innovation and the Internet of Things. And the primary motivation or objective for the talk is to discuss how mobile innovation and mobile phone innovation is really a key part in leading the way with the Internet of Things. As a brief agenda, I'm going to provide some background initially, then discuss some of the main elements of mobile innovation, from networks to devices to cloud and software. And then lastly, I'm going to talk about some of the ramifications for business and society. Okay. As a start, though, I want to talk about how the Internet of Things is really about a change in the things themselves. So, of course, there's the network and the aspects of smart contextualization. But ultimately, the things are changing and themselves developing, having communication capability, as well as some processing capability, really becoming computers just the way the phones have over the last 15 years. Here's a picture of a multi-concept car from Mercedes-Benz with Dieter Zelsche, the CEO and chairman of Mercedes-Benz, doing a presentation at the Consumer Electronics Show in Las Vegas in January. And the car itself has well over 100 central processing units, communications capabilities, and so the concept of the car has changed. And so that's an example of the change in the change in the things, which are really the Internet of Things. As an aside, that the newer cars, even aside from these type of multi-concept cars, already have well over 100 million lines of software code and 30 to 100 processing units. And a lot of the innovation in cars is in regard to this idea of the Internet of Things and providing processing to an end device different than a computer or a phone. Another example of a change in the concept of a thing is the soon-to-be released Apple Watch. There's, of course, other watches on the market today. But here, too, the watch being reimagined, adding a computing power, central processing power to it, multiple sensors, and then communications capabilities. So I think these two examples, really quite high-end, sophisticated examples, are good examples, though, of the potential evolution of the Internet of Things to really be quite transformative. Of course, there are many market segments and many industrial segments. And in other segments, such as agriculture, the actual thing that's changing might well just be something as straightforward or as simple as a water sensor, adding to that communications technology and some processing technology, connecting it to a cloud. But again, there'll be a full range of these types of capabilities and the changes in the things themselves. Here's an example of the latter point. This is from the National Oceanographic and Atmospheric Administration here in the US. But it's using sensors across the Pacific, showing the change in the water level prior to the Japanese tsunami in 2011. So again, relatively simple sensors across the Pacific, connected then into a cloud type of network, and then providing a great deal of capability. Again, the change in the thing itself, the change in the water level sensor by adding some processing and some communications capability. This type of capability, of course, can be used for great societal benefit. In advance of the Japanese tsunami, the Japanese warning system, again in the Pacific, notified the Japanese automatically. And through the system they developed, they were able to slow down the Shinkansen trains and really lessen the risk to human life from train accidents. As a definition of the Internet of Things, I think a really good one, because it's so straightforward, is the ITU one, International Telecommunications Union. Again, not talking about smart really not talking about contextualization or geolocation, really just talking about connecting physical and virtual things based upon current and evolving ICT technologies. And I think this definition encompasses the types of things we've talked about, with relatively simple agricultural sensors all the way up to the Mercedes-Benz multi-concept car or the Apple Watch. The Internet of Things itself is building upon the great changes of mobile phones and internet and smart devices. And every year, Mary Meeker, analyst at Kleiner Perkins, a venture company in Silicon Valley, gives a presentation on the reinvention in the world due to the mobile phones. And some of the highlights, for example, are the change from physical encyclopedias, Encyclopedia Britannica, after a 200-year history, to something that's online. Advertising moving from newspaper to internet, and now more and more to mobile. The possible connections of news with crowdsourcing, and then the great changes in music. These changes are truly with mobile phone and not in internet, and not going yet to the Internet of Things. But with the Internet of Things, there's additional changes that are possible, and most likely innovations we'll be seeing where we're connecting the devices along with the mobiles and the back-end cloud computing. So what will be changing, and what the potential is for large-scale changes in processes and services from the connections of the devices, such as the car or sensors or healthcare type of sensors, to databases and cloud computing. So I think the ITU definition is quite a good one, and one that links together the evolution in mobiles and mobile phones to this newer concept of connecting things together, and actually changing the things themselves to add this type of mobile phone capability. For context on it, how quickly technology and actually society has changed over the last decade or two. Just 2 years ago, passed for the first time 6 billion mobile phone subscribers in the world. And that impact is really worldwide. So it's certainly developed countries, but also developing a little bit less so some rural areas, but really one of the most rapid technology adoptions in world history. 91 billion mobile apps downloaded in the year 2013. That was from close to zero with the start of the iPhone. And various projections regarding the Internet of Things of the number of connected devices by 2020. So of course these include cars and sensors and healthcare devices and watches, water systems and electrical grid, but all of these types of things now having the computational power to some extent and the communications capability. In a chart, ITU puts out these charts once a year on mobile phone adoption, and as you can see on the far right-hand side, almost 100 subscribers per 100 population worldwide. So a quite rapid adoption, and we'll see that more and more as things become internet and mobile enabled. And as technology background, and as a picture of how things will progress in the future, the three enabling capabilities are the processing power on the upper left, moving from about 2,000 cycles a second from the first Apple computer or the first space landing crafts up to 6 and 7 gigahertz now. The transmission capacity in the bottom, the first transatlantic submarine cable only was able to carry 48 calls simultaneously, now millions and millions of calls. And on the right-hand side, storage, now terabyte of storage costing less than $50 US. The first gigabyte storage was only from 1980, commercially available, about the size of a refrigerator and costing $40,000. So these trends are continuing and will make their way into the mobile phones, but also make their way into the things, such as the cars and the watches, which comprise the Internet of Things. So I think that's a big part of the change and the transformation is the continuation of these trends. Mobile innovation, then, is a key component of the Internet of Things. And as a next part of the talk, would like to go through some of the elements of mobile innovation and how they fit together, not just in mobile phones or in tablets, but also in other types of devices and units. The networks, of course, so many countries now, as you see on the right, on 4G LTE, with upload and download speeds ranging anywhere from 2 megabytes per second up to 12. But continuing rapid innovation, ultimately moving towards 5G, and with that, speeds in the gigabytes per second. So very large changes. Of course, not all of the things connected to the Internet of Things would need speeds like this. Primarily just ones related to video or high-end data processing. And many Internet of Things have low data transmission needs, but the networks themselves becoming much more capable, much more robust, and much more ubiquitous. And so network capability, a large part of Internet of Things. A part of the network change, too, is the layering of multiple types of networks, including Wi-Fi as well as 3, 4G, and potentially 5G, but also some of the smaller cell types of technologies too. So network change being a very large driver of what we'll be seeing down the road. And as I mentioned earlier, the rapid advances in processor speed for transmission and processor speed, as well as for storage, it's not just been an increase in capabilities, but also a rapid decrease in cost per unit. ARM from Cambridge in the UK, a leader in mobile processors as well as Internet of Things processors. The bottom right is a family of Internet of Things processors that ARM has out. These are operating the gigahertz range, so really quite capable, high quality, rapidly decreasing prices. And here too, these types of changes being translated into the types of things that are connected and possible. Also too, the dynamic random access memory changing quite advances, progressing quite rapidly, and decreases in cost. Picture on the left is a Samsung new 4 gigabyte DRAM recently released, and then the flash memory also advancing quite rapidly. Again on the right, a new Samsung one, 128 gigabytes. But again, the costs, the decreasing costs, making these types of technologies more and more possible for thousands and millions of things. Again, the thing itself is actually changing, becoming computer-enabled and reimagined with these types of mobile technologies. Sensors too, many companies doing fantastic work on sensors. On the left, an example from the Tricorder X Prize competition, motivated by the Star Trek program from years ago, to develop an all-in-one device that can do multiple types of medical sensing. These are the 10 finalists on the left. These types of devices, including pulse oximeters, glucose detectors, heartbeat detectors, temperature thermometers, all in one, all different sensors. And I think that's part of the promise too of the Apple Watch and other of these wearables, the potential of adding sensors to them, having a communication of some sort, Bluetooth or other, back to a larger processing unit such as an iPhone or tablet, and then connecting that to a cloud or some sort of computing computational capability. The sensors have advanced quite rapidly over the years too, and even more and more so, ranging from agriculture to home to medical devices. But I think this is one area where the advances will be still quite rapid from here. In addition to the advances in the sensors, the advances of how to connect them together and add them to a thing or to a car, for example. Obviously, the batteries and power management are a big aspect of Internet of Things and mobile. Many of certainly with the car, the battery being quite important, but even for also in a different way, a remote agriculture or ecological or monitoring device where the battery can only be changed once a year. This is actually a recent paper. Part of the team is Stephen Chu, the Nobel Prize winner, but it's on a purely lithium anode, and with the thought being that having lithium anodes could increase the power of batteries, the lifetime by about threefold. So innovations like this really quite important, but also innovations in power management, both at the chip level, but also at the software and at the sensor level. And then the operating systems that themselves, many of the Internet of Things devices have scaled back operating systems based upon the mobile phone operating system. This is just from PC World, a comparison of features and functions. These advancing quite rapidly too with each new generation of operating system or version, both at the display level, but also at the features and functionality level. And again, these types of capabilities, perhaps in a streamlined version, but adding on a thinner type of thing, such as an agricultural device, but even on a much more complex version in automobiles or with multiple types of systems. And then the apps themselves really changing a lot too. This is an initiative with Apple and IBM, but many initiatives on apps to make them more targeted, context aware, having geolocation capability, the ability to learn, all these much greater usability. So the change in the apps combined with the change in the device capability and communications capability, adding a lot to the potential for connecting devices to the internet. As an example, and as part of the apps, there's also the back-end part of what can be done with analytics, big data that Alexander works on, and cloud. And just as an example of that, many devices now, watches, wearables being connected to health information systems and electronic medical records. This is an example from a mobile app from the Mayo Clinic here in the US. Ability to actually upload information more and more so directly from a device and soon from a wearable right into the patient's electronic medical record. So great potential for that, as for example, monitoring weight for COPD patients, heart patients, just once a day can have and getting feedback from doctors and nurses can have a huge benefit for prognosis. So again, connecting something simple like heart monitor or even a weight scale can have very large benefits. So I think these are the types of technologies from the mobile world that are making in technology capabilities, making their way into devices which are creating the Internet of Things. And I think continued innovation in each of these areas is what will lead to some of the benefits down the road of Internet of Things. Some of the ramifications for society and potential to address major global challenges. Just wanted to talk about several of them. Of course, a main one is smart cities. Just several years ago, the first time the percentage of the world population living in cities exceeded 50%. Many cities experimenting with connecting water systems and security systems, lighting, computer enabling these types of things or devices back into a central operating system.
Jean-Pierre.
Yes. Okay. Oh, thank you. Back into a central operating system, and then being able to provide better city services. So I think urbanization, obviously, the one that gets the most of the news, but one where there have seen benefits so far and will continue to do so. Transportation, obviously, too. Aging society, many societies are aging quite rapidly. The Asia-Pacific societies, Taiwan and Japan, the US to some extent, and Russia, some of the European countries, but also developing countries. 30% of developing countries are projected to have over 20% of their population being seniors by the year 2050. So the ability to connect the devices and wearables and provide services to seniors and promote social inclusion, for example, and better health, a big potential and a major global challenge. Chronic illness, too, I mentioned the monitoring, health monitoring, very important in chronic illness. An example of Mayo Clinic. This is a picture from India, which has the world's highest incidence of diabetes. So India, developing country, but challenges of chronic illnesses and potential for computationally enabling devices. Just as with the urbanization, worldwide chronic illness recently surpassed communicable diseases as the major cause of death worldwide. So a challenge for many developing countries with the risk of not having good health systems in place before they have a major incidence of aging society and chronic illness. And then the last two areas, economic growth. ICT being recognized as a major enabler of economic growth and international competitiveness, and mobile phones being a large part of that. Possible to see that, for example, with Kenya with the mobile banking M-Pesa, but also India and around the world. It's providing access to services to millions and billions of people. And the Internet of Things enabled by these mobile technologies will be similar. The picture on the right is from APEC. So the APEC region, including United States and Russia, showing the economic growth. APEC being the most rapidly growing economic grouping in the world, but also approaching about 50% of the world's GDP. The one on the left is just the differential of growth in US states. And then security, lastly, potential too. The upper right, again, it is really quite simple, but the idea of counterfeiting or being able to identify counterfeit drugs just through a tag or a code, again, being connected to the back end. Example from, many examples from Africa, but also from around the world. The example on the bottom right from Japan with the tsunami warning system for trains, and then on the left, a monitoring system in Baltimore here in the US. Again, connecting together the different parts of the city infrastructure to provide better safety for the citizens and the population. So in summary, the mobile technologies really a key part of the evolution of the Internet of Things and adopting this technology framework, whether from the processors to the storage, to the sensors, the operating systems, to the innovation in mobile apps, being ported to things now such as cars and watches and medical devices and agricultural devices and smart home. And I think what the outlook is as these technology capabilities for mobiles continue to advance, then we'll see the potential for, and the promise for Internet of Things actually come to bear. So I'd like to thank Alexander and Alexander for the invitation, and hope that was somewhat of an interesting background on mobile technologies and Internet of Things. Thank you.
Thank you, Jean-Pierre. Thank you for putting together a big picture and very detailed presentation of important aspects. It is not easy, we know, and thank you for this, elegant work. Just a minute, our boss will ask. Thank you very much. It was good enough communication, and we saw your presentation. Thank you, Jean-Pierre.
Thank you, Alex.
Thank you.
Thank you.